Hey, so I want to teach you this thing called the distance formula, or the formula for the distance between 2 points on a number line. Sometimes we want to know how many spaces or units there are between 2 points on a number line, because that can represent how much something changed, how much the temperature went up or down, or how much elevation someone went up or down. And so it could be an important thing that's sometimes really easy to find and sometimes not, and that's why we have a formula for it. So this isn't one of the examples that I want you to copy in your video or on your homework. This is me just sort of starting the explanation. So let's say we have a number line, and I don't know, over here is maybe like -10. So over here could be like +10. In the middle is 0. So this could be -1, -2, -3, -4, -5, -6, -7, -8, -9. Oops, I got a little bit off there, but whatever. I'm not going to number all these just for the sake of keeping the video a little bit shorter. But here's +1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now let's say, where's -5? 1, 2, 3, 4. Here's -5, and maybe this is +4 over here. 1, 2, 3, 4. And we want to know the distance between these 2 points. Well, what you could do is just count the spaces. You could start at 4 or start at 5. It doesn't matter where you start, and just count, making sure that you move one before you count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 spaces between these 2 points. And the way you would write that is that the distance between 4 and -5, or 5, -4, it doesn't matter which way you write it, equals 9. But what if I asked you to find the distance between -1,000,000,012 and +2,814,000,000? It wouldn't be reasonable for you to try to count all those trillions of spaces, right? So we need a rule or a formula that helps us find it more quickly without having to count spaces. Well, if you look at this distance here, what you really have is you have 4 spaces from here to here, and another 5 spaces, so I'll put 4 here, and another 5 spaces from here to here. And it turns out that there is a pretty quick and easy way to get this distance, but we want to make sure that our answer is always positive. And well, we could just do 5 plus 4, but it turns out that adding isn't a good rule for other examples, because if I wanted to do the distance between +4 and +7, this distance here, which I think you can easily see is 3 spaces, well, there's no good way I could use 4 and 7 and add to get a 3. So the rule is actually going to be more about subtraction, and we'll talk about how subtraction works even in this weird case where we had a positive and a negative number. And so we're going to go through 3 examples of 3 different cases of using this distance formula. Before we get started, I'll just show you what the distance formula is. So the distance formula, this should be the first thing you're writing toward the top of that worksheet I've given you, so the way you write it is the distance between a point that we call A and a point we call B equals the absolute value of A minus B. It actually doesn't matter which order you write these letters. You could actually do B minus A. It doesn't matter. It's because the distance from 5 to 4, -5 to 4, is the same as the distance from 4 to -5. So the order that you use the numbers does not matter. The only thing that really matters is that we remember that we're subtracting the 2 numbers. So let's go with example 1. This is the first thing you're supposed to write on your worksheet. And so I'm going to use this ruler and just give myself a nice number line. If you don't have a ruler, just make it as straight as you can on your paper. And this example will be when both numbers are positive. This is sort of like the simplest case. And so I'll put my 0 way over here because I'm going to have positive numbers in this example. Why is that part of the screen blocked? Oh, there we go. All right, so it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's good enough. And now let's say we wanted to find the distance between, how about 3, and I'll use a different color, 3 and 8. So we want to find this distance here. And it should be pretty clear to see that that's going to be 5 spaces, right? 1, 2, 3, 4, 5. So I'll put a 5 up here. And the easiest way to calculate that 5 from an 8 and a 3 would be 8 minus 3. So in other words, this distance right here is essentially their difference. The difference is the number you get when you subtract 2 numbers. So we get their difference. But it turns out that when we look at some of the other cases, it's important that we always use these absolute value bars. Because this one turned out positive for us anyway. 8 minus 3 equals positive 5, which is good. We want a positive number because we're talking about distance, and there's no such thing as negative distance. But we always put the absolute value bars on there anyways, because not every case always turns out automatically positive for us. So we just absolute value every time just to be safe. And so we write it like this: the distance between 8 and 3, or you could write it as the distance between 3 and 8, doesn't matter, equals, I did a bad job of saving space for my equal sign there, but distance between 8 and 3 equals the absolute value of 8 minus 3, and that equals 5. All right, so let's look at another case now where both numbers will be negative. So this one I'll do an orange. And this time I'll put my 0, I'm like way down at the bottom of the screen. Let me move this up. All right, this time I'll put my 0 more over here because I need more negative numbers for this example. So this will be -1, -2, -3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's good enough. Let me label them. All right, and then I'll pick, how about -12? Since I numbered all that way, I might as well use it. And -2. And so we want to find this distance here. How many spaces are there between -12 and 2? Well, hopefully you can just count the spaces, or you can just kind of tell that it's 10. It's 10 units. Well, I know that if it was 12 minus 2, I would get a 10, and I'd be good to go. But that's not what's going to happen in this case. If we try to subtract them, if we just go -12 minus -2, so this might look weird to some people, but remember, the formula says that you're supposed to take the first number and then subtract the second number. And so if the second number you use is negative, you're going to wind up having a minus a negative. You should always be subtracting, even if it's negative. And if I do this, well, -12 minus -2, remember, subtraction just means to add the inverse of the next number. So in other words, subtracting a negative is the same as adding a positive. And this turns out to be -12. If you start, -10. If you start at -12 and you go to the right 2 spaces, 1, 2, you get -10. And so the answer to this is -10. But I don't want to write -10 because I don't even want to have a negative sign on here. Instead, since I know I want a positive 10 to represent distance, I'm going to put absolute value bars around this whole thing. And now I still get 10, and -10 is my answer in here. So this still equals -10. But I'm going to absolute value, let me make sure these bars are nice and tall. I'm going to absolute value that -10, and I get a positive 10, like I want, because I know distance has to be positive. So the way I would write this out is the distance between -12 and -2 equals the absolute value of negative 12 minus negative 2. I've changed them to plus signs now, but it was minus negative 2. That equals the absolute value of 10, which is 10. So that's my answer. All right, and then I'm going to do one more case for you where there's a positive number and a negative number. The formula doesn't change, it's still the same. All right, so I'll flip over to the back and I'll put my number line. And this time I'm going to put my 0 in the middle because I need positive and negative numbers. So this can be 1, this can be 2, this can be 3, this can be 4. We don't need to go that far on this one. Negative 1, negative 2, negative 3, negative 4. And how about we use negative 3 and positive 2. No, we'll go positive 4. Positive 4. All right, so we want this distance. We want how many spaces are there between negative 3 and positive 4. Well, we could just count 1, 2, 3, 4, 5, 6, 7. So the answer is 7. But if I try to do 4 minus 3, I would get 1. And if I try to do 3 minus 4, I would get negative 1. So we need to make sure we do this right because students make a lot of mistakes on this. What we need is, I'll do the positive number first. Remember, it doesn't matter which number you use first. You could do 4 minus negative 3, or you could do negative 3 minus 4. They both work. In fact, I'm going to do them both. Over here, I'll do negative 3 minus 4. And then we're going to use our absolute value bars to make sure our answer turns out positive. And if I do 4 minus negative 3, that equals positive 7, because minus a negative is the same as adding a positive. And so this is the absolute value of 7. I'm working downwards this time. This one, on the other hand, negative 3 minus 4, that equals negative 7. Well, either way, if I take the absolute value of 7, I get 7. And if I take the absolute value of negative 7, I also get 7. So whether you decided to do it as negative 3 minus 4 or 4 minus negative 3, putting those absolute value bars around your subtraction problem, I should say subtraction expression, not problem, make sure that your answer turns out positive, which it always should. And so the way you would write this is the distance between negative 3 and 4 equals that. You get 7 as your answer. All right, so now you're supposed to make your own 3 examples, one where they're both positive, one where they're both negative, and one where one's positive and one's negative.